Hello, welcome to Green Wave Tonight. I'm your host, Donovan DeMilt, and on this fine evening we'll be exploring an interesting and relevant topic, solar energy, the technology of using sunlight to create electricity. As the phenomenon of global warming continues, and industry's dark mark on our vibrant planet year by year grows ever larger, the prospect of alternative energy from renewable, non-fossil fuels has grown as well, with groundbreaking research occurring all over the world. The city of New Orleans, in the year 2007, released into the atmosphere a slew of harmful greenhouse gases, including 105 million pounds of carbon dioxide, along with 21 million pounds of nitrous oxides. These numbers are only growing, putting an area like southern Louisiana at risk, as warming temperatures are wont to cause rising sea levels. In light of this pressing issue, we take a look at some of the solar research intending to reverse these trends.
I, over the past summer, had the pleasure of working in this lab at the University of Toledo in Toledo, Ohio, experimenting with ways to improve solar energy, all with the help of this man, my mentor, Brian Kahn.
Nanoscience has many broad applications in many different fields, such as medicine, catalysis, and solar cells. Here currently in Dr. Terry Biccioni's lab at the University of Toledo, we're currently trying to progress and understand nanoscience at a more deep, fundamental level.
The relatively new field of nanoscience is changing the conventional wisdoms of science itself. Almost all realms of science are affected by this new use of materials on the order of nanometers, including solar technologies. For example, let's take this ring of gold foil, boasting the common characteristics of gold as we know it. But when modified into smaller particles, these conventional characteristics are no longer valid. We've set up a simple experiment to demonstrate the incredible features of nanoscience. Currently, a conventional gold salt in a golden yellow solution is stirring on a hot plate set to boil. These gold salts will react with a reducing agent, transforming into gold particles. And in that transformation, they will lose all of their quote-unquote conventional characteristics. Let's take a look. As you can see, there's an immediate color transformation in the solution.
And as the reaction goes on, the solution begins to get darker and darker as more of the gold nanomaterials begin to form.
Here we have the final gold nanomaterial solution. Its almost blood red tint, clearly a stark contrast from our original gold ring. This interesting red solution maintains a very useful property, the ability to absorb light. Obviously, as a red solution, red light will not be absorbed. But the green light clearly illustrates the incredible potential of these materials, as even a strong green laser is completely absorbed by this gold solution. The ability of nanoparticles to absorb light has been instantly recognized by the solar energy community for its potential in that field. This past summer, my work in this lab was centered around using these materials to stain titanium dioxide-coated glass substrates to make little experimental solar cells just like this one. In this research lies brilliance. This lab, and ones just like it across the country, across the world, move towards groundbreaking discoveries and products each and every day. This little tiny experimental solar cell, this little flat glass box, could one day change the world, reversing the terrible trends of environmental destruction that have become the norm. What an impact one little box can have. What an incredible, implausible, magnificent impact. Through research in solar technology, research in harnessing energy from one of its most basic sources, a little glass box truly can change the world. While Dr. Biccioni's lab focuses on possibilities in the realm of nanomaterials, others explore other technologies, cadmium telluride, cadmium indium gallium diselenide, or even classic silicon solar technologies. Climate change is a major problem throughout the world, and New Orleans is not immune. Such research can put an end to detrimental global transformation, and it is only fitting that Tulane, through our School of Science and Engineering, would be a part of that groundbreaking research. Global warming represents a trend toward rising sea levels that could leave many New Orleans residents underwater. Global warming represents a trend towards stronger, more intense tropical storms that, just like Hurricane Katrina, could wreak havoc on the infrastructure and well-being of New Orleans as a whole. As a southern city, its solar energy potential, and thereby its potential to stem the expansion of climate change, is truly incredible. It really is amazing that these little glass boxes, tools of solar research built to absorb, can actually radiate so much positive energy, so much positive impact potential onto the world around them. Let Tulane and New Orleans continue to work to be a part of this brilliance. Once again, with Green Wave Tonight, I'm Donovan DeMilt. Good night, and roll wave.